What if the oldest thing ever seen in our solar system was never born here at all? And what if the proof of that just came from the one place almost nobody was watching? Before we go any further, take 1 second and hit that like button, subscribe to the channel, and share this video with someone who loves space. Because what you are about to hear is one of the strangest true stories in modern astronomy, and it is still unfolding right now. Let me take you back to the first day of July, 2025. A survey telescope sitting on a mountain in Chile is doing what it does every single night. It scans the sky, looking for anything that moves. The system is called ATLAS. It was built to spot asteroids that might threaten Earth. It finds hundreds of moving dots every week, and almost all of them turn out to be ordinary rocks following ordinary paths. But on this night, one dot refuses to be ordinary. The software runs the numbers, then it runs them again. The orbit does not close. Every object native to our solar system, every asteroid, every comet, every planet, moves on a path that loops around the sun. This one does not loop. Its path is open, stretched, hyperbolic. The number describing its shape comes back at about 6.1. For comparison, a value of 1 is the exact line between staying and leaving forever. This object is not just leaving. It was never here to stay. It came from outside, from another star entirely. Humanity had only ever seen this twice before. In 2017, a strange, flat, tumbling object called Oumuamua swept through and left scientists arguing for years because it showed no tail, no gas, no normal comet behavior. In 2019, a second visitor named Borisov arrived, and that one at least looked and acted like a comet we could understand. This new one was named 3I Atlas. The 3I stands for Third Interstellar Object, and within weeks, it became clear that this thing was stranger than both of its predecessors put together. To understand why that matters, you need to know how the first two visitors behaved, because together they formed the pattern that 3I Atlas broke. Oumuamua, the first one, was a mystery from the moment it was found. It was small, it was dark, and it did something no comet should do. As it swung around the sun, it accelerated slightly, pushed by something, but telescopes could find no gas coming off it. No dust, no tail, nothing. A comet accelerates because ice turns to gas and jets off its surface like tiny rockets. Oumuamua accelerated with no visible jets at all. Scientists argued about it for years. Some said it was a fragment of a frozen world, a shard of nitrogen ice like the surface of Pluto. Others proposed stranger ideas. The truth is, it left too fast, and we learned too little. It was a question that flew past before we could answer it. Borisov, the second visitor, was the opposite experience. It behaved beautifully. It grew a tail. It vented gas. It looked like a comet, acted like a comet, and its chemistry was familiar. Enough to be comforting, with a few interesting quirks. Scientists walked away from Borisov thinking that maybe interstellar objects were not so alien after all. Maybe the galaxy builds comets the same way everywhere. Then, 3I Atlas arrived and destroyed that comforting idea in a matter of months. It was faster than both of them. It was bigger than Oumuamua by an enormous margin. It was active like Borisov, but chemically nothing like it. And as the data poured in, it became clear that the first two visitors had not taught us what interstellar objects are like. They had only taught us that we had no idea how much variety was out there. Here is the first clue, and it is a big one. Speed. 3I Atlas entered our solar system moving at roughly 58 kilometers every second relative to the sun. That is more than 200,000 kilometers per hour. Now, speed in space is not just about motion. For an interstellar object, speed is a clock. Think of it this way. When a comet gets kicked out of its home star system, it starts drifting through the galaxy. The longer it drifts, the more the gravity of passing stars and clouds nudges it around. And over billions of years, those nudges add up. An object that has been wandering for a long time moves faster relative to its neighbors than a young one. So when astronomers measured that incoming speed, they were really measuring how long this thing had been traveling. And the answer made people sit back in their chairs. Early calculations said this object could be anywhere, from 3 to 14 billion years old. More detailed chemical measurements would later push the most likely estimate toward 10 to 12 billion years. Let me put that in human terms. Our sun is about 4.6 billion years old. Our entire solar system, every planet, every moon, every asteroid, formed at the same time. 3I. Atlas may have been thrown out into the darkness more than twice that long ago. When this object began its journey, there was no sun. There was no Earth. There was not even the cloud of gas that would one day become them. The universe itself is 13.8 billion years old, which means this comet has existed for most of the lifetime of the cosmos. It may be the oldest comet ever seen by human beings, and it just flew past us. Now, I want to be careful and honest with you here, because this is exactly the point in a story like this, where exaggeration usually creeps in. Scientists cannot date a comet the way you date a tree. by counting rings. The age estimate comes from two independent lines of evidence working together. The first is that incoming speed I just described, the so-called velocity at infinity, which acts like a statistical clock built by the galaxy itself. The second is chemistry, the isotope ratios frozen into its ice, which record the conditions of the environment where it formed. When both of those clocks point to the same answer, an origin in the deep past, in a colder and more primitive era of the galaxy, that is when scientists start using words like oldest. And that is exactly what happened here. Now pause for a moment and really feel what that means. The ice inside this object froze solid when the universe was young. It stayed frozen through the birth and death of entire generations of stars. It drifted through the Milky Way while our galaxy was still taking shape. And then, by pure chance, its ancient path crossed ours. In the one brief moment of cosmic history when a species existed that had built telescopes powerful enough to notice it. If you find that as astonishing as I do, this is the perfect moment to jump into the comments and tell me your honest reaction, because I read every single one, and your perspective might end up shaping a future video on this channel. And if you have not subscribed yet, this is exactly the kind of deep, carefully researched space story we tell here, so consider joining us for the next one. Now, the discovery itself was only the beginning, because once astronomers knew what they were looking at, a race began. And it was a race against time. An interstellar object is not like a normal comet that belongs to us. A normal comet comes back. It loops around the sun every few decades or few centuries, so if you miss your chance, you wait, and it returns. An interstellar visitor gives you one opportunity, one pass, a handful of months, while it is close enough and bright enough to study. And then it is gone forever, back into the dark between the stars, never to return. Every day of observation lost is lost permanently. There are no second chances with an object like this. So telescopes all over the world, and several in space, turn toward 3I Atlas. Hubble looked at it in July 2025 and measured its coma, the glowing cloud of gas and dust forming around its core. Ground-based observatories tracked its brightness night after night. And then, in October 2025, the comet did something that turned an already historic event into something even more unusual. It swung past Mars. On October 3rd, 2025, 3I Atlas passed. Within about 29 million kilometers of the red planet. In cosmic terms, that is not a near miss, but it is close. Close enough that spacecraft orbiting Mars had a front row seat that no telescope on Earth could match. And this is where the story takes the turn that the title of this video is really about. Because among the spacecraft that turned to look was one that many people in the West barely knew was there, China's Tianwen-1 orbiter. Tianwen-1 arrived at Mars in 2021. It was designed to study Mars, its surface, its atmosphere, its geology. Nobody built it to chase interstellar comets. But when 3I Atlas swept past, the mission team did something remarkable. They took a spacecraft that was never designed for this job, aimed its high-resolution camera at a tiny, faint, fast-moving target millions of kilometers away, and captured images of an interstellar object from deep space. It was the first time China had ever observed an astronomical object from deep space, and they pulled it off on a target that had only been discovered 3 months earlier. The images came in 3 separate rounds of observation around the close encounter, and they showed something scientists could not see from Earth. The coma of 3I Atlas, the cloud of gas and dust boiling off its surface, was changing shape between observations. The tail structure shifted. Features appeared and evolved. This was not a dead, quiet rock coasting through space. This was an active, restless object, venting ancient material into space as the sun's heat touched ice that had not been warmed in billions of years. Think about what it took to get those images. The comet was faint. It was moving fast. The orbiter itself was moving. Pointing a camera at it was like trying to photograph a firefly from a moving train in the dark from thousands of kilometers away. And yet the data came back clean enough to track how the coma and tail changed over time. But Tianwen-1 was only one part of China's contribution. Back on Earth, another instrument was doing something arguably even more important. The Tianwen radio telescope near Shanghai, a dish 65 meters wide, was watching the comet continuously, tracking the water vapor rising off its surface. Radio telescopes can detect the signature of water being released, and by monitoring it over long, unbroken stretches, the team behind that work was able to map how this comet releases its water, hour by hour, day by day. What they found was a water release mechanism that does not behave the way solar system comets behave. The water was not just sublimating off the surface the way it does in our comets. Something about the structure of this object, its layers, its composition, its ancient radiation-battered crust, was releasing water in a pattern scientists had not documented before. And there was something else happening behind the scenes that made all of this matter even more. Astronomy runs on schedules. The great telescopes of the world are booked months in advance. They have maintenance windows, instrument changeovers, engineering downtime. But during parts of the comet's approach, some of the biggest eyes in the sky simply were not watching. China's network was. The distributed set of observatories on different mountains in different time zones, with flexible, automated scheduling, kept their instruments on the comet and kept the record continuous. No press conference, no dramatic announcement. Just steady, unbroken data, archived and shared, filling gaps that would otherwise have been permanent holes in the scientific record of the rarest kind of object in the sky. If you are finding this story worth your time, do me one quick favor. Share this video with just one person, a friend, a family member, anyone who has ever looked up at the night sky and wondered what is out there. That single share genuinely helps this channel reach more curious minds, and it takes you less than 5 seconds. And if you are new here, subscribe, because we are following this story all the way to the end. All right, now we arrive at the heart of it, the discovery that turned 3I Atlas from an interesting visitor into something that scientists have openly struggled to explain. In December 2025, as the comet was heading back out after its closest approach to the Sun, the James Webb Space Telescope locked onto it. This was the perfect moment. Solar heat had warmed the comet's surface, and its ices were turning directly into gas, streaming off the nucleus in huge quantities. That gas is a message. Every molecule in it carries information about where and when the comet formed. And Webb is the most sensitive instrument humanity has ever built for reading that kind of message. It split the light from the comet's coma into a spectrum, a chemical fingerprint, and started reading. And the first thing that jumped out was the water, or rather, what was inside the water. You have probably never thought about the fact that water can come in different versions. A normal water molecule is 2 hydrogen atoms and 1 oxygen atom. But there is a heavier form of hydrogen called deuterium. It has an extra particle in its nucleus. When deuterium replaces regular hydrogen in water, you get what scientists call heavy water. It is real, it is natural, and it exists everywhere, including in the oceans under your feet right now, but always in tiny trace amounts. Here's the important part. The ratio of deuterium to normal hydrogen in water is like a birth certificate. It tells you the conditions under which that water formed. Water that forms in extremely cold environments, close to absolute zero, ends up enriched with deuterium because the chemistry of the deep cold favors it. Every comet in our solar system carries a deuterium ratio that fits a pattern matching the conditions in the cloud that formed our sun and planets 4.6 billion years ago. 3I Atlas shattered that pattern. The water coming off this comet carried a deuterium level roughly 30 times higher than typical solar system comets, and more than 40 times higher than Earth's oceans, 30 times. That is not a rounding error, that is not a marginal oddity. That is a composition so far outside everything ever measured in our solar system that it does not fit any known reference point. Researchers compared it to comets, to the oceans, to the atmospheres of giant planets, even to the star-forming clouds near us, the places where new suns are being born today. Nothing matched. Nothing even came close. Martin Cordner, a scientist at NASA's Goddard Space Flight Center who led one of the key studies, put it plainly. This object does not match our solar system. It does not match our comets. It does not match the nearby regions where stars are forming. It is something new and different. So what does it take to make water that heavy? 2 things. Extreme cold, colder than almost anything we see in the modern universe nearby. And time. Enormous stretches of time for that slow, cold chemistry to build up. Put those together, and the environment they describe is one that existed only in the early galaxy, billions of years before our sun was born, in dense, frigid molecular clouds of a kind that may not exist in our cosmic neighborhood anymore. And it was not just the water. Webb also measured the carbon in the comet's gases, and the carbon told the same story, from a completely different angle. The ratios between different forms of carbon in its carbon dioxide and carbon monoxide were unlike anything in our comet catalog. 2 independent chemical signatures, hydrogen and carbon, both pointing in the same direction. This object was born in conditions so cold, so early, and so primitive that our current models of the universe have very few places to put it. Then came another shock, this time from the ratio of carbon dioxide to water. In the comets we know, water is king. Carbon dioxide is a minor ingredient. In 3I Atlas, that relationship was turned on its head. The comet was venting carbon dioxide at levels dozens of times higher relative to its water than any comet in our solar system. That suggests its ices formed far from their home star, out where carbon dioxide freezes, in the coldest outer darkness of some ancient planetary system. or it suggests that billions of years of cosmic radiation, as the object drifted between the stars, chemically reworked its outer layers, possibly both. And while all of this was happening in the world of data and spectra, something else was happening in the world of public attention, and you deserve the honest version of that too. An object this strange, moving this fast, with numbers this extreme, was always going to attract wild claims. And it did. Social media filled up with theories that 3I Atlas was not natural at all, that it was a probe, a ship, an artifact. A few prominent voices amplified the speculation because the object's behavior had genuine oddities. And oddities are fuel for anyone who wants to believe. But here's what actually happened when the data came back. Every single measurement from Hubble, from Webb, from ALMA, from the Mars orbiters, from the radio dishes, told the same story, and it was not an artificial one. It was a comet, a real, natural, icy body, doing the things icy bodies do when sunlight warms them, just with a chemistry and an age nobody had ever recorded before. And honestly, that truth is far more interesting than the fantasy. A machine built by someone else would tell us we are not alone. But a natural object older than the sun, carrying chemistry no model explains, tells us something just as profound. It tells us that the galaxy's own history is stranger than the versions of it we have written down. The reality did not need any embellishment. It was already, on its own, one of the most remarkable measurements in the history of astronomy. And in March 2026, yet another instrument added a new layer of strangeness. ALMA, the giant array of radio dishes high in the Chilean desert, detected something unexpected pouring out of this comet. Methanol, alcohol, in enormous quantities, more than almost any known comet. Molecule by molecule, this object was proving to be chemically alien in almost every way we could measure. Now here's where China's role and the global effort locked together into one picture. The continuous tracking from China's observatories, the deep space images from Tianwen 1 at Mars, the unbroken water monitoring from the Tianwen telescope, these were not side contributions. They anchored the timeline. They told every other instrument exactly where the comet was and how bright it was at every stage of its approach. That baseline is what allowed Webb and ALMA and the rest to confidently connect each chemical measurement to a specific moment in the comet's journey. The chemistry that revealed the object's impossible age rests on a foundation of tracking data that nobody could afford to lose, and that almost was lost, and that China's network quietly preserved. Before we go deeper, if this video has earned your attention so far, there's a small bell icon next to the subscribe button, and ringing it is the only reliable way to make sure you see our next report the moment it drops, because stories like this one develop fast, and YouTube will not always show them to you unless you tell it to. It takes one tap, and it genuinely makes a difference for a channel like ours. Let us now step back and ask the deeper question, what is this thing really? The honest scientific answer is that 3I Atlas is a piece of a planetary system that no longer exists. At least, not in any form we would recognize. Here is the leading picture. Somewhere in the early Milky Way, a star formed. Around it, a disk of gas and dust. In the freezing outer reaches of that disk, small icy bodies formed, the same way comets formed around our own young sun. Then, at some point, gravity did what gravity does. A giant planet, or passing star, or the slow churn of the young galaxy, flung one of those icy bodies out of its home system entirely. Not into a wider orbit. Out into the emptiness between stars. And there it drifted. For 10 billion years, give or take. Try to hold that span of time in your mind. While this object wandered, stars were born, burned, and died. The Milky Way's spiral arms slowly rotated. The cloud that would become our solar system gathered itself together, collapsed, ignited, and built planets. On one of those planets, oceans formed, life sparked, cells multiplied, fish crawled onto land, dinosaurs rose and fell, mammals inherited the earth, and eventually a primate species learned to grind glass into lenses and point them at the sky. And in all that time, through all of that history, this lump of ancient ice simply traveled, silently in the dark, preserving inside itself a frozen record of a time and place that nothing else remembers. Then, in 2025, its path happened to cross ours. There is a word scientists use for objects like this, and it is a beautiful one. They call them archives. An interstellar comet is not just a rock. It is a sample return mission that the universe sent us for free. Every frozen molecule inside it is a data point from an era our telescopes cannot otherwise reach. We cannot point Webb at the early galaxy and take a scoop of its material. Physics does not allow that. But the early galaxy, it turns out, can send its material to us. And when 3I Atlas warmed up in our sun's heat and released its ancient gases into space, it was, in a very real sense, opening a time capsule that had been sealed since before the Earth existed. That is what made every hour of observation so precious, and It is why the continuous coverage from Chinese mountaintop observatories to a Chinese orbiter at Mars to radio dishes listening for water vapor ended up mattering so much. A time capsule that opens once for a few months and then closes forever is not something you want to watch through a gap in the record. Now, let me address the word in the title that brought many of you here: terrifying. Let me be completely honest with you, because you deserve honesty more than hype. 3I Atlas was never a danger to Earth. Its closest approach to our planet was roughly 270 million kilometers, farther than the distance from Earth to the Sun. Nothing about its trajectory threatened anyone. If you were hoping or fearing that this was the object that changes life on Earth, it was not that. But here is what is genuinely unsettling about it in the deepest and most interesting sense of the word. For most of modern history, we treated the space between stars as essentially empty. A void, a gap between the places where things happen. 3I Atlas, together with Oumuamua and Borisov before it, has killed that idea. The space between stars is not empty. It is full of debris, full of wanderers, full of fragments of dead planetary systems drifting through the dark in numbers we are only beginning to estimate. Some astronomers now calculate that trillions upon trillions of such objects are moving through our galaxy right now, each one a frozen record of some ancient, vanished world. Our solar system is not a sealed garden. It is a crossroads. Things pass through it that were born before the sun, and we are only now, in this exact decade, building instruments sharp enough to notice them. And there is a second layer to this that is even more quietly profound. The chemistry of 3I Atlas does not fit our models. The deuterium is too high, the carbon ratios are off, the carbon dioxide is overwhelming, the methanol is abundant beyond precedent. The scientists working on this data have said, carefully but clearly, that no environment we have measured so far fully explains this object, which means one of two things is true. Either the early galaxy contained conditions we have not yet imagined, or our understanding of how cometary chemistry works over 10 billion years of interstellar travel is incomplete. Either way, a single icy wanderer just exposed a gap in human knowledge in public, in the pages of the world's most prestigious scientific journal. That is the real terror, if you want to call it that, not a rock falling from the sky. A reminder delivered in person that the universe is older, stranger, and less understood than our equations assumed. A reminder that we are surrounded by ancient travelers we never knew existed. And a reminder that noticing them at all, catching a faint moving dot in one survey image, keeping telescopes pointed at it across continents and across the gap between Earth and Mars without interruption, is a fragile, difficult, deeply human achievement. It is also worth saying clearly what the collaboration in this story shows us. The data that cracked this object's secrets did not come from one country, one telescope, or one team. It came from a patchwork. A survey telescope in Chile built to protect Earth from asteroids. A space telescope parked 1 million miles away. A radio array in the desert. A Mars orbiter that was never designed for this job, but rose to the moment. Mountain observatories running through the night, while bigger facilities were offline. Science, when it works best, is a relay race. And in this race, the baton passed through hands on every continent. The Chinese contributions were not a footnote to that effort. At critical moments, they were the effort. The Tianwen 1 images from Mars gave researchers viewing angles no one else on Earth or in Earth orbit could provide. The Tianwen monitoring revealed a water release behavior no one had documented before. The continuous ground coverage stitched the whole timeline together. If you have stayed with me this far, you are exactly the kind of viewer this channel exists for, so here is my request. Drop a comment below telling me where in the world you are watching from, and what part of this story stunned you the most. The global map of curiosity in our comment section is honestly one of my favorite things about making these videos, and your voice adds to it. So where is 3I Atlas now? It is leaving. As this video reaches you, in the second half of 2026, the comet is well on its way out of the solar system, past the orbit of Jupiter, dimming as it goes. The coma that glowed so brightly is collapsing back into nothing. The gases it released are dispersing into space. Soon, its ices will lock shut again in the cold, and the object will return to the state it knew for 10 billion years. Silence, darkness, drift. It will never come back. Its path does not loop. It will wander the galaxy for billions more years, long after every human being alive today is gone, long after every telescope we built has crumbled, carrying its impossible chemistry toward whatever comes next. But here is the part that should stay with you. We did not miss it. A species that only invented the telescope a few centuries ago happened to be looking with instruments spread across a planet and all the way to Mars. At the precise moment one of the oldest objects in the galaxy came within reach. We photographed it from the orbit of another planet. We read the chemistry of ice that froze before the sun existed. We tracked its breath, molecule by molecule, as it warmed for the first time in 10 billion years. And when the great telescopes blinked, smaller, steadier eyes on distant mountaintops kept watching, so that the record of this once-in-eternity encounter stayed unbroken. The message it carried was not a warning. It was something better and stranger. It was proof that the galaxy remembers, that the early universe left artifacts of itself scattered through the dark, and that every one of them is a page from a history book we have barely begun to open. 3I Atlas was the third page we ever managed to read. The first two told us almost nothing we could agree on. This one told us that out there, beyond everything familiar, there are objects older than our sun, built in conditions our best theories cannot yet explain, and that they are passing through our neighborhood, whether we watch or not. The only question is whether we keep watching. And this is the final piece of the story, the part that turns one strange comet into a permanent change in astronomy. 3I Atlas was found by a survey telescope that was not even looking for interstellar objects. It was looking for asteroids that might hit Earth, and it caught this wanderer by accident as a byproduct. But a new generation of sky surveys is now coming online, led by the Vera Rubin Observatory in Chile, with a camera so powerful it will photograph the entire visible sky every few nights. Astronomers estimate that surveys like this could find interstellar visitors not once every few years, but potentially several times a year. An entire hidden population of ancient wanderers is about to become visible, which means 3I Atlas is not the end of this story. It is the first chapter of a catalog, the opening entry in what will become a library of ancient objects, each one a frozen sample from a different corner and a different era of the galaxy. Some will be young, some will be like Borisov, familiar and comforting, and some, if the pattern holds, will be like 3I Atlas, older than the sun, chemically impossible under our current models, forcing us to rewrite what we thought we knew. Every single one of them will be a message in a bottle, thrown into the cosmic ocean by a star system that may have died billions of years before ours was born. And for the first time in human history, we have the nets to catch them. The next one is already out there. Somewhere in the sky tonight, another ancient traveler is drifting toward us, carrying chemistry from a star system that died before ours was born. Maybe it will arrive next year, maybe next decade. Maybe a survey telescope has already photographed it without anyone noticing. Yet, when it comes, the same race will begin again. The same fragile chain of telescopes and schedules and human dedication will be tested again, and the record we keep will once again depend on whether enough eyes in enough places are open at the same time. So I will leave you with the question that the scientists themselves are still sitting with tonight. If one random object from interstellar space turned out to be older than the sun, chemically unlike anything we have ever cataloged, and born in conditions no existing model fully explains, then what else is drifting past us in the dark, and how much of the universe's real history is still flying by, unread? Think about that the next time you look up. Thank you for spending this time with me. If this story changed the way you see the night sky, even a little, like this video, subscribe if you have not already, and share it with someone who needs to hear it. And if you want to know exactly where 3I Atlas went after it passed Mars, and what its escape path reveals about the structure of our galaxy, that is the next video on this channel, so make sure you are here for it. Something visited us from the dawn of the universe. We watched it arrive. We watched it breathe. We watched it leave. And because a few dozen telescopes on a small blue planet refused to look away, its story is now part of ours, forever.